third one. All right. All right. I don't know what y'all are laughing about. We're focused. Focus. What do those terms in number one, what do they have in common? They have a 3, but what's bigger than that? 6. Do they have any x's in common? No. All right, so we write down the GCF, and we put the leftovers in parentheses. So we divide the 6 out of each of those. Remember, we're not getting rid of the 6. We're just writing it out here. This is factored form. And so that will leave me 3x minus 2. Okay. So if you could do distributive property to check. Now, distributive property isn't a guarantee way that you did it right, because you could have done this. You could have said, like, oh, they both have a 3. And when you distribute, you still get that back. It's just a helpful check. It's not a 100% guarantee you did it correct. So you always want this that you pull out to be the greatest thing that they have in common. Yeah, the biggest thing that you can take out, that's what you want to take out. No, it's not a full credit. Yes, always, partial credit. What do 21 and 35? What's the biggest factor that goes into them? Okay, and how many x's do they have? 2. All right, so then you divide that out of each one, and that leaves you 3x in the first term and 5 in the second. Who got that one? Perfect. All right, excellent. And then the last one, it might have taken you a few minutes. What did 15, 60, and 90, what's their GCF? 15. They actually have lots of stuff that goes in. 5 goes into all of them. 3 goes into all of them. But the biggest one that goes into all is 15. What's the most m's that they have? All of them. 2. And the most n's? 3. So then you're dividing that out of each one. Oh my gosh, so much writing. Okay. And then in the first one, what's left over? The 15s are gone. Are there any m's left over? 1 m. Any n's? No. Okay. And then the second term is minus 60 divided by 15. Any m's left? Any n's? 1. And then what's 90 divided by 15? 6. Any m's left? N's? No. So that's it right there. What we're doing today is this, but multiple times in the same problem. This is called factor by grouping. Grouping. This is where you're going to start with something that has 4 terms in it, okay? But first, before we even get to that problem, I want to do these sort of level 0 problems, and we're going to build up from here. In numbers 1, 2, and 3 here, there's actually 2 groups of things going on. So let me highlight them so you can see. There's this group, and then this group. What we're going to do is GCF both of those separately. GCF just like we did yesterday, but it's going to look a tiny bit different, okay? Looking at both of those groups together, compare them together, and tell me what the yellow group already has in common with the blue group, the y plus 7. So that is their GCF. So it's a little bit different form from yesterday. Yesterday, our GCFs, if you look back at the warm-up, this was a GCF, these were the GCFs. There's no plus or minuses in there, right? But today, our GCF will have a plus or minus. So how does it affect it? It will help. This right here is going to help us do those 4 terms down there. So we put down what they have in common, the y plus 7. We're still going to divide out that from each of those groups. So this is still my GCF. My leftovers, quote unquote, are still going to go in the other parentheses. What's left over in the yellow group when you divide out the y plus 7? 3y. Okay, so that's gone. Leaves you 3y. And what about in the blue group?
Minus 4.
Minus 4. And that's your answer. Well, for these are just sort of setup problems. It's not the actual problems that is our goal for the day. So you try 2 and 3 and see what you come up with. You ready? Let me go through these real quickly. You ready for real quick? So you're grouping these two. What's the GCF in the first group? And then what's the leftovers? Okay. What's the GCF in the second group? 3. So you write that here. What are the leftovers? And then what do these have in common? And what's left over in this group? And this one? Okay, who got that?
We did it, Gus. You're so smart. Yeah. You want to be a physicist. Exactly. Yeah. I gotta learn this. For a skater. That's how you do a kickflip. There's the formula for it. Right there. Yeah.
Good?
Yeah.
B times A plus 7 for the first group. 8 times A plus 7 for the second. And then they have A plus 7 in common with B and plus 8 as the leftovers. All right. Feel good with that? The only reason we have the problems on the back is because there's a little bit different thing that I need to point out to you on those problems. So these are with subtraction. So right here, this subtraction sign on each of these makes a difference in how you're going to think about these problems, that subtraction in the middle. Let me show you the wrong way of doing it, okay? That will get you stuck. No, because I need to show you this because otherwise you're going to do it. So sometimes that's true, but I feel like it's important in this case to show you what not to do. If you were doing it like normal and you were just moving along, like bopping along, not really thinking, and just doing math, you would look at the second group and go, oh, they have a 2 in common, and you would divide it out, and you would get negative x minus 3. Why is that problematic? No, they don't have anything the same, right? The negative is with the 2. So anytime you have a minus right here, when you do the GCF for that group, you want to make the GCF a negative. So the first group's still the same, but yeah, when you divide out a negative 2 from this second group, look at what happens. Negative 2 divided by negative 2 is positive 1. And what is negative 6 divided by negative 2? Positive 3. And now you have that same thing, okay? Do 3 and 4 real fast, and then I'll give you your worksheet for the day. It's really short, so we'll still have time. I don't know how we got all this talking and all this work done. Hold on, let me just check that you got this answer right. So I put my work up here. Don't look